Question number one wants us to find the dimensions of a rectangle with area 1,000 square meters whose perimeter is as small as possible. So basically, what I know is we're going to have a rectangle, and we're going to call the length x and the height y. So there's two ways we can express this thing. If we go ahead and call this y and this x, we know the perimeter is 2x plus 2y. And we want that to be as small as possible. So that means we're going to attempt to minimize that. And the other thing we know is that the area is 1,000 square meters. So x times y equals 1,000. So now, the thing we're trying to minimize is 2x plus 2y. That has too many variables. Remember, our two conditions are one variable simplified. So we're going to rearrange this equation. I could choose either one. I'm going to go ahead and say y is 1,000 over x, which means my equation now can become 2x plus 2 times, instead of y, 1,000 over x. And that's what we're attempting to minimize. So that is what we're going to take the derivative of once we simplify. So we're going to have 2x plus 2,000 over x. And that's going to be what we refer to as our function. So the next thing we're going to need is the derivative. The derivative of that thing is 2. 2,000 x to the negative 1 becomes minus 2,000 over x squared. So from our derivative, we're going to find our critical values. So the first of our critical values is what would make this undefined, so x equals 0. Now, that one doesn't count because it would make a rectangle with no width, so that isn't going to apply to this problem, but technically it is a critical value. The other critical value is going to be when 2 minus 2,000 over x squared equals 0. So if I bring the 2,000 over, we now have this equation, which means x squared equals 1,000. So x is 1,000 square rooted, or negative square root of 1,000. Again, for practical constraints, the negative goes away. So that's my x. If x times y is 1,000 and x is the square root of 1,000, then y is also the square root of 1,000. So those are my dimensions. It wanted me to find the dimensions, so I don't have it to do anything else to the problem other than to give units. So this is the square root of 1,000 meters by the square root of 1,000 meters. And we want to justify that that actually is the minimum. So we're going to take this second derivative. The second derivative, coming from the first derivative, is going to turn into positive 4,000 over x cubed. X being the square root of 1,000 is going to give me 4,000 over the square root of 1,000 cubed. I don't know what that is, but I do know it's greater than 0, which makes it concave up, which means we have found a minimum. So my answer is here.